Good morning to all. In the previous session, we have studied some examples, some assembly language programs and being executed in the assembler which I have used is EMU 8086. In today's session, we'll be going into detail about stack structure of 8086. And one more thing, in the previous session we have discussed arithmetic operations, assembly language programming, and for more programs I will give the hints in the PDF. So using that hints you can able to program, you can able to write assembly language program. Clear? So in this today's session we are going to discuss about stack structure of 8086. So how a stack will be, what is a stack? A stack with example, what are the stack operations which are push and pop, what is the difference between push and pop, and how the stack register will be functioning with an example. So what is a stack? Stack is nothing but memory where you can able to store a temporary data or address. The stack is a temporary storage or store data and address. The CPU may push important data on the stack while it is processing the other data. So stack is nothing but temporary storage of data and address. So depending upon the requirement, the CPU may push the instructions which are very important, which will be top of the stack in order to execute in the stack. So in between, while the processing is being done, in between the CPU may push the important data onto the stack. So the stack follows principle last in first out. Nothing but what are the instruction which is on the top of the stack or which is pointing to the stack pointer will be executed first. So now this is the stack. For example, we have 1, 2, 3, 4, 5. So top of the stack which is pointing to the stack point, which will be pointing by the stack pointer is the top, which is top of the stack. These are very important instructions that store and retrieve data, that can able to store the data or retrieve the previous information from the data. It follows the last in first out stack memory. The two main functions of the stack is push and pop. Push means adding the item to the top. Pop means remove the item from the top. So for suppose stack is empty and you are writing an instruction push 7. So it will be pushing the 7 first. So there are no instructions. So only top of the stack is 7. Next is we want to push 8. So it will push the 8 above the 7. Next we want to pop 8. Nothing but remove the 8 which is pop 8. Now if you want pop 7, again it will become as empty stack. So simple example how you are using this stack using push and pop. Push, adding an item in the top of the stack. Pop, removing an item from the top of the stack. Yeah. Coming to the format, how you have to write and what it will do about the description. So first thing is we want to push onto the stack. So what the mnemonic and format we need to write is push with the source operand. The source operand, suppose we have bx. Push bx. So what it will do, it will point the stack pointer. So we want to push nothing but in the top of the stack we want to first empty it. So it will point to the sp -2. Then after SP minus 2, it will add one position SP plus 1 to the pointer which it is source. So the source will be added into the top of the stack. Pop from the stack, the instruction is pop, format is pop destination. So the destination will be first SP plus 1 pointing to the stack pointer and SP plus 2 pointing to the stack pointer. So this will eliminate the or remove an item from the top of the stack. Next, push the flag with the help of mnemonic, push F, which will be pushing the flag into the top of the stack. Popping the flags with the help of pop F from the top of the stack. Same operation how we have used your push and pop. The thing is, here the operands will be pushed or the data will be pushed into the top of the stack and popped from the top of the stack, whereas here flags will be pushed to the top of the stack and flags will be popped from the top of the stack. These are important instructions that restore and retrieve data, the LIFO stack memory. So there are 6 frames of the push and pop. So push register, push an instruction, push a register, push a memory, immediate, segment register, flags and all registers. So these are the 6 frames which we can use the help of 2 stack operations which are push and pop. So we can write push an instruction, push the instruction, pop the instruction, push the register, pop the register, put the memory, pop the memory, push the immediate data into the top of the stack, pop the immediate data into the top of the stack, push the segment register directly into the top of the stack, pop it, pop the flag, push the flag. Okay, so whatever the push, what it does, it push up the opcode, push opcode copies the data from the source address to stack. Pop opcode copies data from the stack to the destination address. So in this fashion, push means the data will be pushed into the top of the stack. Pop means top of the stack, whatever the data is there is being removed. This is top, this is bottom. Difference between push and pop. The key difference is when an entry is pushed onto the stack, pop is when the last pushed entry is popped off the stack. Only one difference, push the tag, pushed onto the stack, popped off the stack. For example, push dx, push dx, push dx, push dx. So first it will put cx in the top of the stack, then push dx, so dx will be top. Now pop first dx, remove, pop again cx, so empty will be stack. Stack register in 8086 stack register is stack pointer SP. The stack segment register is usually used to store information about memory segment that stores the call stack of currently executed program. Stack pointer points to the current stack top. Now setting up a stack by loading the SS and SP register. Stack segment label word, it is in the top of the stack. In the stack segment, word is being stored 30. Then code segment starts, move AX comma, whatever stack segment is there, it will be stored in AX and AX to SS. Then move SP to offset to S, initialize the stack pointer, and so on. This is how the syntax for your setting up a stack by loading the SS and SP register. A small example, move AX, 2, push AX, pop AX, move DX, AX. These are for interrupt and start. We'll see with the help of EMU 8086. I have already done the program. Simple. I have loaded a AX value with 1234H, and I am pushing the AX to the top of the stack. And again, I am loading the value AX, 567H. Now I am popping the AX. Nothing but removing the 567H. If I write here itself, it will remove thing. Save. Go for emulate. It will go to view, you can see the stack, right. Now single step, so 0700 is CS, SS is 0700, so it is 0700, so single step. Now AX has 1234H, push AX, you can see here, the top of the stack, it is 1234H. Now again I am loading with AX as 5678. Next we are going for pop AX. So AX is stack is top of the stack is 000. Now AX value has been 5678, which is being removed. So this is how you can able to code the stack program and see the functionality. So you can use, depending upon the requirement, push pop and see the functionality. So some program to find out odd numbers and even numbers in a given series of 16-bit hexadecimal. I will copy this code and we will see. In order to go to new COM template, yeah, just copy paste here. Sorry. Maybe the data is there. So same thing, even an odd example, save it. I've taken an array of numbers through which we want even separate and odd numbers separate in a memory. Compile, it will executable file, yeah, then close, then go to emulate, step by step process, then go to view, here we will see memory. So single step, data 0710, so store here 0710 and update. You can able to see the numbers what I have given in the data segment will be stored in the memory. And see one by one, single step, first count will be how many numbers, 8 numbers I have given, so count is now 8. Here you can see CL as count. Now source index is 000H. So I am using an XOR operation because if anything is there in your destination index register, it will be make as 0. As you all know the XOR operation. Then I will also XOR BX in order to make BX as 000. Now move the whatever the array of offset of array stored in source index. Now back loop I am taking and move AL content, sorry, SI content to AL. So it will first store The first number is 80, so it will store in AL. So AL content I am moving into the AH. So I am using here shift right operation to one time. So if the shift right, if any carry exists, you can see the carry flag. If any carry exists, then you need to go to loop 1, otherwise go for next instruction. We don't have carry, so it will store as even number of px. See here, 80 is being stored as even number, right? Then go for inc bx, bx will be incremented, jump skip, increment si, second one, decrement cl, 7, next jump if non-zero, it is non-zero, go to back, so same one. So it will check and it will store as, see this is the odd number, so that's why it is 05. Then it goes step by step in the same fashion until it becomes a 0, the count becomes 0, it checks, now it is 0, so it has been stopped. So now these are my even numbers and these are my odd numbers. So like this you have to write a program in order to separate odd and even numbers. Thank you. So this is how the stack structure will be. Thank you.